Hello and welcome to first lecture in the fifth chapter of our comprehensive course on AI, ML and DS. In previous chapter, we did some discussion about basics of Numpy library. Now we are doing discussion about some advanced features of Numpy library. And more important is this thing, importance in data science. So although in one earlier lecture I told you that the real data science will start still after maybe a few chapters, but slowly now we are moving our course focus from pure programming to programming that is required in data science. Okay, so let us discuss these topics: reshaping of NumPy arrays, stacking, and splitting. Among that, the reshaping we had already done, but just as a revision, quick revision, we are doing this. We know this thing. That suppose I have this NumPy array, which is a 1D array at present, and I want to convert it into a 3x4 array, 3 rows, 4 column array. Then I can use the reshape function. Okay, and this is how we do it. That also we know, we have done earlier in previous chapter. Import NumPy and create first 1D array, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And arrange means the last number will not be included. And if step size is not specified, then the default step size is 1. So this will create an array of numbers from 1 to 12 like this. Okay. Now I want to reshape it so that it is converted into a 3 row and 4 column array. So then it is easy. I have already got 1D array. Just write array.reshape and number of rows, number of columns in the parenthesis separated by comma, and you will get the reshaped array. We had already done that. One extra thing also we had done that say array reshaped 2, suppose I say, is equal to, I can do all these things in one step only. np.arrange 1, 13. That means that 1D array which is shown above, that will be created, and then dot again. So now that dot and this reshape function is applicable to that 1D array which was created by np.arrange 1, 13, and we then reshape it 3 to 4, and then 3, 4, and array underscore reshaped array shaped d. Okay, shaped 2. Let us print it, and in one step you can get the same thing what you got in the previous one. Fine. Reshaping we had already done earlier, so I'm not wasting much time here. But where it is used, so it is used in preparing data for algorithms which require specific input shape. And there are many algorithms which are a little bit tricky about the input data. So format of the input data, that they require only this kind of rows and columns format only. They will not accept data if it is not matching with their specified format. So at that time, it is not at all difficult. You can reshape your 1D array anyhow, and you can even reshape, say total there are 12 elements, so you can even reshape in a different way. For example, 2 rows and 6 columns. So in that case, I can reshape, you can say 2 rows and 6 columns, or maybe 6 rows and 2 columns. So as long as the product of this number of rows and number of columns is equal to this total number of elements in the array, then you can arrange any different types of array. Let me make it what it was. That means it was a 3x4 array. Okay, fine. Now stacking. Now this is something new. So from this point onwards, I will be going a little bit slowly. Stacking is the process of joining a sequence of array along a new axis. Now there are several ways of stacking. For example, H stack, horizontal stacking, V stack, vertical stacking, D stack, depth-wise stacking. Okay, so let us take all examples. Then only just stack. When you specify, then what happens? Whether default stack creates H stack, V stack, D stack, what it creates. And similarly, same stacking can also be attained by same result can also be obtained by one another function, that is concatenate. However, as such, one may feel that this the single command concatenate remembering would be easier because it can handle H stack, V stack, D stack, any type of stacking. Yes, it can, but with concatenate, the syntax sometimes becomes a little bit tedious. So my advice is, though it is my duty to show you all possible variations, but you should not be bogged down by all these variations that there are so many different ways of achieving. You just have to remember these 3, actually only 2, H stack and V stack, because even depth-wise stacking is also very rarely required. But say if you want to remember that H stack, V stack and D stack, and that is the names are very indicator: horizontal stacking, vertical stacking, and depth-wise stacking. Let us start with the first. So this is a 1D array having 3 elements, 1, 2, 3. And this is another 1D array, 4, 5, 6. So it is 3, comma means how many say these have 3 members, and it is 1D array, so comma just means there is no dimension other than that. Okay, and similarly these also have 3 members. Now I want to create another 1D array which is having all 6 members, that is 3 of these and 3 of these, and it should also be a 1D array. So then one method is np.hstate a comma b. And remember this outer parenthesis is because every function, its arguments are passed in a parenthesis. But the inner parenthesis, you must remember that the two arrays which you want to extract, that you have to pass as a tuple. Okay, so a comma b. Fine. There is another way of doing the same thing, that is np.r underscore, and then in a list a comma b. Now this is different and this is different. This is not even actually a list, but these two are different. So let us see first what is, similarly we state if you want vertical stacking. That means I want at that time 1, 2, 3 and same 4, 5, 6, but I want to put 1, 2, 3 above 4, 5, 6. So this time what will happen in horizontal stacking? Original two arrays are 1D and the new array which is created is also 1D. But in vertical stacking, original two arrays are 1D, but the new array which is created will be a two-dimensional array. It has 2 rows and 3 columns. So there also the method remains exactly the same as hstate. np.hstate, here np.vstate, vertical stacking. Okay, and this parenthesis is because it is a function, and inside you have to pass a tuple of 2 arrays. Whatever first array you pass, that will become the first row, and second array you pass, that will become the second row. Let us first create this vstate example. So this is creating a 1D array, np.array, and then list 1, 2, 3, and similarly np.array. Let us just check that we get the desired 2 arrays or not. So yes, we are getting the 2 desired arrays. Okay, and then I am now doing vertical stack np.vstate. Outer parentheses are because they are passed as in a function, and in inner, I think there seems to be something wrong with this picture. Actually, it should be list and not tuple. Okay, yes. So it gives a 2D array. So please correct this picture whenever you get it. It should be as a list. Okay, let me try to pass a tuple. Mostly it will not work. Okay, let us do that. No, it has worked. So fine. Then that means you can pass either a list or a tuple. Both will work. Fine. Now then, this is vertical stacking, but now I can do. Okay, first this is concatenation I want to do afterwards. First, somewhere. Okay, let us take other examples because I think extract example etc. are not given by code. Okay, so fine. Let us take a few more examples. Now, if I want that horizontal stack, this np.extract, then in that case is equal to np.extract. As I said, outer parenthesis would take because it is a function, and inside you can pass the 2 arrays as a tuple, a and b. Okay, so if you pass 2 arrays as a tuple and press Control Enter and then horizontal stack, then you are getting this array. Okay, so that is horizontal stacking, and this is vertical stacking. There is one another type of stacking which is column stacking, about which we will talk afterwards. But first, this horizontal stacking can also be obtained in this manner: np.r underscore, and then in a square bracket first array and second array. So let us say horizontal stack 2 is equal to np.r underscore, and then in this first 1D array and second 1D array, and then let us horizontal stack to print that, and let us see that it is also giving exactly same result. But this I personally do not, so this is a little bit concise. I personally like this because it clearly says that arrays will be 2 arrays will be joined horizontally. So it is like just extending one array and then concatenating the elements of the second array below it. While here vstate clearly says that 2 arrays will be joined vertically, one above another, one above another. Okay, and in vstate the order is in hstate also. The order is important. For example, here you write b comma a, then obviously b will become elements of b will become the first row, and 4, 5, 6 becomes first row, and so you have to take care what you want. Okay, and similarly here also order matters. In hstate also, element of b, if you write b comma a, then elements of b will come first, followed by elements of a. So 4, 5, 6 come first, followed by 1, 2, 3. Okay, here. So that is also fine. Even in the np.r also, if you change the order, then obviously your result will also change the order. That also you can see. Let me undo everything and make everything as it was originally. It was AB, and here also it was AB. Fine. Anywhere else I have changed? No. Fine. Okay. Now this somewhere here, this concatenate I will still take afterwards, but first I have to take this example. That is the column stack. Okay. Same 1, 2, 3, and I am just for the sake of clear visibility, first printing A and B, and then using this command np.column underscore stack. Okay. So then And this time I can even include everything in the print right from the beginning. Np dot column underscore stack. Again, order matters, so I write A comma B. Now, column stack is a special type of stacking. It tries to minimize the number of columns, but tries to include all the possible number of elements. So that means what is happening here? There are 3 and 3 6 elements, and 3 and 3 6 elements should be put in 2 rows, but so rather 2 columns, but 3 rows. Okay. So then, what is the issue? Column stack takes one positional argument. Why? Oh, sorry. I forgot one parenthesis. Right. So I'm getting the input which is similar to output which is similar to this. Let me paste this here also for your convenience. So that each time, because I'm going to provide this Jupyter notebook to all the paid students, so at that time they can refer this thing readily and they don't have to scroll up and down. So this is that column stack. Okay. And if you want to achieve the same column stacking by a different method, then that different method is here. Like that, stack requires R underscore A comma B. R stands for row. So stack is also called row stack sometimes. Similarly, this is called column stack sometimes. Okay. So then print np dot R underscore A comma B. That is sorry, C underscore, because here it is column wise. And there also you get the same result as this. Okay. Now there is only even one more method of achieving column stack by using horizontal stacking, which looks a little bit strange, because horizontal stacking is actually joining the elements in same one dimension along same axis as the original two arrays are there. But you can write this kind of notation, that np.h stack a colon. But again, I would personally prefer to remember one more command than column stack, that is. So rather than remembering such a esoteric type of syntax. Okay. So h stack and a, and then in which you have to write colon comma none. Colon means for the first dimension you have to write everything possible, and for the second dimension you don't have to take anything. Okay. That is the meaning of colon comma none. And similarly D, and there you have to write in a different manner, colon comma none. So again, for first dimension everything possible, and for second dimension nothing. Okay. So then let us see what these gives as the output. So I can put a print here only, rather than saving these as a result and then printing and all that. That also gives same output. But personally, I will not try to remember so many different syntax. This concatenate, let me take, and let me even add a few blank cells to differentiate between the topic. Okay. I will personally not like to remember all these different syntax. See, if you want to obtain column stack, then why go roundabout and first use X stack and then from that column stack? Or even why use this, though this syntax is concise. If you can remember, then this np dot c underscore ab, that is a good syntax. And similarly np dot r underscore ab for row wise concatenation, and this is for column wise concatenation. Both these are good syntax. But I personally prefer to remember these three: H stack, B stack, and then column stack. Column stack is a slightly different result than vertical stacking. Okay, vertical stacking is not column wise stacking, that you have to understand. This vertical stacking just does what? Takes first one dimensional array, takes another one dimensional array, and puts just one above another. So that what is happening is the number of columns in the first array is 3, number of columns in the second array is also 3, and number of columns in the resultant array becomes also 3. But number of rows increases by 1. While in column stacking, what is happening is again 6 elements are there, but number of rows increases by 1 and number of columns decreases by 1. Okay, so that means number of rows actually increases by 2 if you compare with the original. So that means this is first row, this is second row, and still one more row. So from where the elements will come from one more row, obviously the 3 and 6 will have to be shifted down. Okay, and that's why it has become 3 rows but only 2 columns. That is what is this column stack. Okay, so column stack always tries to increase the rows by 2, and V stack tries to increase the rows by 1 compared to the original one-dimensional arrays which you are using as argument. Okay, fine. Now here I will do concatenate in the next lecture. Thank you.